The purpose of this video is to familiarize ourselves with how to make a sign chart for linear factors, or linear expressions. Now, there's nothing too particularly exciting here, but it's a good starting point for when we start to solve complicated inequalities. The first example I'll do will be, I'll say, to take this expression here, x minus 5. I'm going to make a sign chart for it. And what that means is it's an indicator of where this expression is positive, where it's negative, and where it's 0. How this goes is we plot the values of x that make the expression 0. I mark them down on the line, so I'll just say here, I'll say when x is 5, the value of the expression is 0. So I put my x values above the line, and I put the values of the entire expression corresponding below the line. So the first thing that you're always going to want to mark is where it's equal to 0. So if x is 5, the value of the expression is 0. And if x is anything larger than 5, 6, 7, 8, 9, 10, or anything above, the value of the expression will be positive. Now this is just a sign chart. It's just to tell us what is the sign of this expression for any particular value of x. So the reason that I don't mark any numbers down here is because all of these numbers above 5 produce the same result. Anything that, so long as x is above 5, the resulting expression will be a positive number. The way that you should probably think of this is, or the way that I think of it is, numbers greater than 5 minus 5 are positive. So we just kind of mark this whole thing with a plus sign, and then the opposite of that is anything that's less than 5. Numbers less than 5 minus 5 are negative. So I write a negative sign there, and that completes the sign chart for x minus 5. You'll notice it's very similar to just a regular, a simple one, if just x. All right, if x is 0, then the value of the expression is 0. And if x is greater than 0, we say that the value of the expression is positive. And if x is less than 0, the value of the expression is negative. Pretty much all of these are going to be they're basically all going to look just like this, only at different values of x, depending on what's surrounding it. So I'll do another example here. I can say maybe x plus 10. Alright, where is it positive, where is it negative, where is it 0? I want a sign chart to tell this to me. So the first thing that you want to write down is the value of x that makes it equal to 0. So at negative 10, if x is negative 10, then the value of the expression will be 0. And you can see that if x is larger than negative 10, minus 9, minus 9, minus 8, minus 7, 0, 1, 2, 3, 4, 5, any positive number, anything larger than negative 10. If x is anything larger than negative 10, then the value of this expression as a whole will be a positive number. And if x is less than negative 10, right, minus 11, minus 12, down to minus whatever, numbers that are less than minus 10 plus 10 will make the expression negative. So that's how this stuff works. And there's a couple things that I want you to notice. All right, notice that they all kind of look exactly the same, right? They all go plus, minus, plus, minus, plus, and minus, plus. So there's always a sign change, and that's an important part of this. If you're dealing with a linear factor, just talking about a linear factor, you're always going to get a sign change across the value of x that makes the expression equal to 0, right? So when you see this, you should think, if we can see that, when you see x minus 5, what you should think in your head is that the value of the expression is going to change sign if x is on either side of positive 5. Just like x is, the value of the expression is going to change sign here whenever x is on either side of minus 10. And basically they're all the same as just this regular one here. Clearly, I mean, it's obvious in this case, but these two examples are basically the exact same thing. We're just adding a number to x, and it just shifts everything by the appropriate amount. Another thing that I want you to notice is that if I take any of these expressions, the x minus 5 or x or the x plus 10, and I multiply the entire thing by a positive constant, so let me just do that over here so you can see what I mean. If I had, say, 3 times x minus 5, or say 10x, or I could say 22 times the quantity x plus 10. If we were to make sign charts for these things, had the original problems, or had the original examples started out this way, absolutely nothing would have changed for the answers, right? At 5, it would still be 0. Right? The zeros won't change because the values of x that make them 0 are going to make them 0 no matter what's out front. So minus 10 and 0. And as long as x is in the region that makes this expression a positive number, this expression a positive number, this expression a positive number, multiplying the result of this by another positive number isn't going to change anything. So if it changes nothing about the sign chart. It'll change the values of the outputs, right? Like, for example, if you make x equal to 6 here, then the output value is going to be positive 1, and if you make x equal to 6 here, the output value is going to be positive 3, but it won't change the sign. And for purposes of a sign chart, only the sign matters. So, two things so far is that you will always get a sign change, right, across the value of x that makes it equal to 0. And having a positive constant out front does not change the sign chart. So if the problem had started out as just this, what you could do is just ignore that 3 and just do the rest of the problem, fill out the rest of the sign chart as though it's not even there, because it's not going to affect it. It doesn't matter. Now, that's not to say that whenever there is a multiple that nothing will change. For example, on occasion you might have to do some work if it turned out to be, say 3x minus 5, something a little bit different. Right? These two things aren't the same, right? But what you want to do, a pretty good practice to have for these is to always make it so that it looks like this before going for a sign chart. So when I have this 3 that's next to the x, I don't like where that is, so I'm just going to factor it out. So I'll factor 3 out of the entire expression, and we'll have 3 x minus 5/3. And then we can proceed from here. So again, we would just treat this exactly in the same way as we treated the other one. We know that this 3 isn't going to modify our sign chart at all. All the action is here. All right? The problem is basically this. The 3 doesn't really add or take anything away. We're only doing a sign chart. The 3 out front won't affect anything. So again, I write down the value, mark off the value that makes it equal to 0, and in this case it's 5/3. So I write when x is 5/3, the value is 0. And if I plug in a value of x that's greater than 5/3, it could be any number, 6/3 or 7/3 or 1 or 2 or 3 or 400 billion. Whenever you take 5/3 away from all those numbers, these x values over here, we will get a positive result. And if x is less than 5/3, numbers less than 5/3 minus 5/3 give us a negative result. So it's just as easy as that. Now, they don't all go from negative to positive like this. It really depends on the individual expression. For example, if we had started out with, say, we'll do an easy one. We'll say 7 minus x. 7 minus x. So what's going to happen here? You do it pretty much the exact same way. You mark down where it equals 0. So what value of x is going to make this expression equal to 0? So 7, obviously 7 minus 7 is 0, so I mark down 0. And then you got to think to yourself a little bit. If x is larger than 7, all right, 8, 9, 10, 11, 12, 50 billion. As long as x is larger than 7, I think to myself, 7 minus a number that's larger than 7 is going to be negative. It's going to be less than 0. So I'd be sure to write this down with a negative sign here. And then I can think my way through it. Although it's a little bit more complicated, if x is less than 7, say 7 minus 6, 7 minus 5, etc., etc., the value of the resulting expression is going to be positive. So they don't always go from negative to positive like this, but they do always change sign. And that's the important part of doing this. When we go to solve complicated inequalities, it's handy to know that you're always going to get a sign change across the values of x that make the expression equal to 0. As long as it's a linear factor, that's important to remember. As long as it's a linear factor. Now, if you understand that, then there's really not a whole lot that I could do to make this tough. Because we're only dealing with linear factors, we're kind of limited in the kinds of problems that can be given here. But I could, for example, say, make me a sign chart for 3 minus 4x. Alright, tell me where is it positive, where is it negative, where is it 0. Or I could say, well, I'll just do this one first. So you want to know where is it positive, where is it 0, where is it negative. I don't like how this looks here. I have a coefficient that's attached on the x. So what I'm going to do is I'm going to factor out. I'll do this in a couple different ways. But remember that this is the original expression that I'm starting with. I'm going to factor out. I'm going to ignore this. Factor out a 4. If I factor a 4 out of this expression, what I wind up with is 4 times the quantity 3/4 minus x. Alright, and then I can proceed to make the sign chart from here. I just mark it down. Where is it equal to 0? It's easy to see when it's written out like this. Maybe not so much like this, but like this. It's easy to see that the expression is going to equal 0 whenever x is equal to 3/4. So I write that down, and then I just think if x is larger than 3/4, I just choose a large number and plug it in. Not really worried, because we're not worried about the value of the output. All right, we're not worried about the value of the expression, only whether it's positive or negative. So I just think x is a really large number, because any number larger than 3/4 will suffice for doing this. So I usually just pick a number in my head like 50 billion, and I say 3/4 minus a large number is going to be a negative number. And the 4 out front isn't going to affect that, right? As long as this thing is negative, multiplying it by 4 isn't going to change its sign. So 3/4 minus a large number, or minus a number larger than 3/4 is going to be a negative value. Now I don't even have to think about it, because I know that linear factors will always change sign. I can just go ahead and mark down a plus sign here. But if I don't trust it, I can always plug in a number anyway. I think 3/4 minus a number that's less than 3/4. So 3/4 minus a small number is still going to be positive. Or even if x is negative, right? 3/4 minus a negative number is definitely going to make this whole thing positive. And the 4 isn't going to matter. So this is what the sign chart is going to look like for that. Now that's if I factored out a positive 4. An alternate version of this is if I factor out a negative 4. And just to see how this works, if I went to negative 4, what would the interior expression look like? Well, it would be minus 3/4, say, plus x. Now, I don't really like how that looks, because I don't like having a negative number out in front here. So let me just switch that up, and I'll say minus 4 times the quantity x minus 3/4. So let's go back to this again. Alright, I want to mark down where is it equal to 0, and it's easy to see. At 3/4, the value will be equal to 0. And then here comes the part that's a little bit more tricky. You might think that, well here, if I plug in a number larger than 3/4, 5, 6, 7, 8, 9, 10, 50 billion, a large number minus 3/4 is a positive number, but don't forget that after that, this expression will be positive as long as x is greater than 3/4. But just this piece of it, after you plug in a value of x and work this out, get some positive number, you're going to multiply the result by negative 4. Now because it's a negative number out front, the sign is going to change from positive to negative. And then the same thing happens on the other side of 3/4, right? If x is less than 3/4, then this piece will be a negative number, right? Numbers less than 3/4 minus 3/4 are negative numbers. But then when you multiply that by negative 4, the result becomes positive again. So you just have to sort of be careful. If there's a negative number out in front of it, you just have to be aware that there's the possibility of maybe switching signs. Now, earlier we did the ones where most of these ordinarily, if we're not playing any games with like negative coefficients or negative, if the negative sign isn't attached to the x or whatever, they'll always go negative, positive, and so on and so on. It's only when something weird is happening, right? If the x has a negative out in front of it, that the thing is going to change. I don't recommend remembering this as a hard and fast rule, but just be aware of it when you go to make these sign charts, that they don't always go negative, positive. But the important thing to remember is that they do always change sign. So we always get sign changes. So really, if we do enough of these, if you get good enough at them, you only have to worry about filling out one of these sides, because you know that the sign is going to change when you cross over to the other side. Let me do one more, something that might look like it's intimidating, but it's really not too bad. I could say 3x minus 5 all divided by, say, 4. If I want to make a sign chart for this, I want to know where is it positive, where is it negative. Let me zoom in for a second. Where is it positive? Where is it negative? Where is it 0? And as with the other ones before this, there are a couple different ways of interpreting this. When I don't see this as a division problem. I see it as a multiplication problem. I have a tendency to look at this as though it's 1/4 times the quantity 3x minus 5. That way. So that way, since it's a positive number out front, I'm free to ignore it for purposes of doing up my sign chart. All I have to worry about is what's going on with the 3x minus 5. So I'm going to do it that way. And I'll say, once again, I'll just mark down the values of x, or the value of x that makes it equal to 0. Now, you could do that by setting the inside equal to 0. Or another way, so yeah, why don't I do it that way? Because it's a little bit different from the way that I did the other ones. And the other ones, I factored out the 3. In this case, I'll just set this whole expression equal to 0, right? I get 3x minus 5, just do a little side work, equals 0. And you bring over to 5 and divide by 3, and you get x equals 5/3. So that's one way of doing it. So we could do it that way. So I'll have 5/3 here. X equaling 5/3 makes the whole thing 0. And then we can see that if I plug in a number larger than 5/3, again, it doesn't have to be a specific number. It could be any number larger than 5/3. So I'll pick what's convenient. I'll go with 400 billion. And 3 times 400 billion minus 5 is a positive number. And the 1/4 isn't going to affect anything, so I'm free to ignore it. So that'll be a plus. And I know that I'm going to get sign changes over here. So when I know that when I cross over 5/3, it's going to switch to a negative number. That's one way to do it. Pretty much the same exact thing. I'll do it again, is to start from here. If we take out the, if we factor the 3 out of this, we could instead get 3/4 positive number out front times x minus 5/3. There's your 5/3 that we got in the other problem. So mark down where it's equal to 0, and clearly at 5/3 it's 0. And if we plug in a number larger than 5/3, you'll get a large number. 40 billion minus 5/3 is a positive number. And then I know, because of the way that all of these go, that if I cross over the 5/3, I'm going to get a negative number. The 3/4 out front doesn't change anything. In fact, we really could have just thrown this away from the beginning, right? When we started out with this thing, we have 3x minus 5 all over 4. That's all. The focus is really here. All right. What's going to determine the sign of this is just the numerator, because since the bottom is just a positive constant, it's not going to affect anything, so we don't have to worry about it. But, you know, whether we include it or not doesn't make a difference so far as our sign charts go. But that's the way that all of these pretty much go. I could say, maybe I'll do one last example. Something let's go as crazy as I possibly can. We'll have, like, I'll say minus 3 times the quantity 2 minus, let's say 7x. So this one has the 3 out, has a minus out front and a minus on the inside. So let's see how this is going to go. Again, I don't like there being a negative or a coefficient on the x, so I'm going to factor it out. I'm going to factor out a negative 7. And when I factor it out of here, that'll combine with my negative 3, and that'll give me 21 times the quantity what? Alright, when I take out the negative 7, I'll have an x, or I guess I'll have a minus 2/7 on the inside plus x. And I like to rewrite this. I don't like having negative numbers in the front like that, so I'll say 21 times x minus 2/7. And then from there, it's a piece of cake. All you got to do is mark down the values of x that, or the value of x that makes it equal to 0. So clearly, it's going to be 0 at 2/7. The value will be 0, and you can see how these go already. If x is larger than 2/7, pick a large number, plug it in. Large numbers minus 2/7 are positive, and as is always the case when we switch over across 0, the sign of the entire thing is going to be a negative number. We don't have to worry about this 21 out front because it's just a positive constant. It could have been any positive constant, and we only would have had to concern ourselves with this. And that's how to make sign charts for anything that looks like it's for any single linear factor. Once again, the important parts are the fact that there's always going to be some spot where it's equal to 0. You mark that one number down, and to one side of that 0, it's going to be positive or negative, and you just have to plug in a number and test it out. And on the other side of that 0, it's guaranteed to switch the sign of the entire factor. So it's going to be whatever it is over here, it's going to be just the opposite on this side. And like I said, there was nothing too exciting in this video, but if you understand this, then it's going to make it a heck of a lot simpler when we start solving inequalities for these. In fact, while I'm here, we could do these inequalities, we could do these as though they were inequalities from the beginning. Let's take all, I won't do all of them, but I'll start with, say, here. If we wanted to solve this inequality, let's say x minus 5 is less than or equal to 0. Suppose it started out just like that, and suppose further that we didn't know that we could just bring that 5 over, alright, and say, oh, the answer is x is less than or equal to 5. Suppose that we didn't know how to do that. What you could do is, you would make a sign chart for this expression. Ignore the fact that you're solving an inequality. Just make a sign chart for this. Boom, boom. We already did it. And then you look back at the problem and say, what am I looking for? I want to know, where is this expression less than or equal to 0? Where is this expression a negative number or 0? So you just look at your sign chart and say, oh, that's easy. It's when x is less than or equal to 5, which is the answer that we got from solving it algebraically. Same thing goes for, I'll say, this one down here. Suppose that at first what we wanted to do was solve the inequality 22 times the quantity x plus 10 is greater than 0. You say, okay, forget about that. Make a sign chart for this expression here. And so you make a sign chart just like we just did, negative here, positive here, and then refer back to the problem. What's it asking for? It wants to know, where is this expression greater than 0? So you would know, oh, okay, I'm going to take these ones, and the solution is going to be x is greater than minus 10. And of course that'll go with any one of these. This one up here, say, 3 minus 4x. If I want to know, where is 3 minus 4x less than 0? Alright, you say, I have no idea, but I'm going to make up a sign chart and figure it out. So you do your sign chart like we just did, and then you can read the answers straight off of this. Alright, if the original problem is asking for this, forget about this, make a sign chart for it, done. And then go back and say, which one am I looking for? I want less than 0. So you just look at the numbers on the sign chart and then you see, oh, I want these answers. The solution has to be x is greater than, we want x is greater than 3/4, which is, of course, the answer that you would have gotten algebraically. And lastly, I guess I'll just do this one last. Suppose that the original problem had started out like this, and I wanted to solve this inequality. Where is this expression greater than or equal to 0? So this is the original problem. Without doing any algebra, of course we could do the algebra, but the purpose is to use the sign chart. So what you would do is you would do a little bit of algebra here, put together the sign chart for it, and see, okay, the expression is negative here, it's negative in this region, and it's positive in this region. So then you go back, and it's looking for, it wants to know, where is this expression greater than or equal to 0? So then you look on your sign chart for the plus sign, and we want to know, it's right there. So the solution is x is greater than or equal to 2/7. If x satisfies this condition, it will necessarily make this expression greater than or equal to 0, and that's how it's done.